Ladies and gentlemen, thank you for standing by and welcome to Assessing the Performance of Flood and Coastal Erosion Risk Assets to Guide Management conference call. Before we begin, I must advise you that today's web seminar is being recorded and that all participants are currently in a listen-only mode. Our presentation today will be followed by a question-and-answer session. To ask a question via the audio, please press star 1 on your telephone keypad and wait for your name to be taken by an operator. To submit a question to the presenter, please type your question into the Q&A or chat panel at the bottom right-hand corner of your WebEx screen. Finally, if you experience any technical difficulties during today's web seminar, please press star 0 on your telephone keypad or send a chat message to web support. Now, without any further delay, I would now like to hand the conference over to your first speaker for today, Alan Tarrant. Thank you. Please go ahead.
Thanks, Cherry. Thanks for that introduction. Good morning, everybody, and thank you very much for taking some time out of your busy work schedule today to listen to this webinar on asset performance tools. Just going to move through the slides just to outline the agenda for today. So I'm going to give a bit of an introduction to our research program to give you some context behind the project, introduce why we're doing this research and the project team that have delivered this research project. And then I'm going to hand over to John Wicks at Jacobs, and John's going to take us through a bit more of an overview of the Asset Performance Tools project, the framework, and then the tools that have been developed underneath that framework. That will take us to about 11:15, where we're going to take a very short 5-minute break, a rest break, and we're then going to split into 3 parallel sessions where we're going to dive into a little bit more detail about some of the research products that have been generated by the project. So these 3 parallel sessions, the first one is going to be flood defence performance, where we'll hear from Jonathan Sim at HR Wallingford, and then whole life costing, where we'll hear from Alec Yowell at Jacobs. So anyone who wants to listen to those more detailed webinars, can I ask you to hang on to this presentation? We've got further 2 breakout sessions that are going to be running concurrently. So if you want to hear about watercourse conveyance maintenance, then you're going to have to dial out of this webinar and use the links on the agenda that you received. I'll post those links again in a minute, and where we'll hear from Marta Rocker at HR Wallingford. Or if you're interested in beach management and setting triggers for intervention in beach management, then again you'll dial out of this webinar, use the link in the agenda to select the appropriate conference, where we'll hear from Jaap Flikvert at Royal Haskoning DHV. Okay, so we'll complete the webinar, all of that webinar, by 12 o'clock today at the latest. Just to put some names and faces to voices. So I'm Owen Tarrant at the Environment Agency. I'm the Asset Management Theme Lead within the Joint R&D programme. Just to introduce the project team and the presenters today, Petra Neve at Jacobs has been the Sterling project manager for this piece of work. We'll be hearing from John Wicks at Jacobs, Alec Yowell at Jacobs, Marta Rocker from HR Wallingford, Jonathan Sim, HR Wallingford, and Jaap Flikvert at RHDHV. Just to go over some of the housekeeping, as Cherry mentioned at the start of the webinar, it is being recorded, and the breakout sessions themselves will be recorded as well. We're going to be publishing those recordings. They're going to be available from our research pages, the web links there. The easiest way to find our research pages is actually just Google. So if you Googled Flood Research Environment Agency, it will be the first thing that pops up in that Google search. So I encourage you to go and have a look at those web pages. phone lines are currently muted for this plenary session. They're not going to be muted for the two breakout groups, the beaches and the channels. So if I could ask you, if you're joining those webinars later on, could you please mute your own lines going into those webinars, please? We'll be taking some questions at the end of this session, at the end of John's presentation. But if questions come to you as we're presenting and discussing the research, please use the chat function and just fire them across. I'll be keeping an eye on those and collating those, and then I can direct them to the appropriate project team members. So yeah, please get in contact with us if you've got questions via the chat function. So I'm going to just start off with a poll. Hopefully you should be able to see on the right-hand side of your screen a poll there. To open that poll now, could I just ask you to select one of those categories and affiliation there, just so we can get an understanding of the distribution of attendees to this call. I'm just going to give you another 15 seconds to do that. Right, I am going to close the poll in 5, 4, 3, 2, 1. Ooh. Software is doing it for me, sorry. Okay, thank you, that's great. Ooh. Sorry, missed that. Okay, so that's great. I'm seeing some results on my screen, and we've got a good mix across all of those categories, especially strong representation from the Environment Agency and consultancy, which is great. That's exactly the audience we're trying to target, and some not good representation from the lead local flood authorities, coastal authorities, and other. So that's great. That gives an indication of our audience. Thank you very much for participating in that poll. I just want to now give you a bit of background about the R&D programme itself and where this project fits within the joint programme. So the joint programme is exactly that. It's jointly managed and funded by the Environment Agency, DEFRA, Natural Resources Wales and Welsh Government. And the research programme is to deliver research for all of the risk management authorities in England and Wales on issues of flood and coastal erosion risk management. So it's not just an EA-led programme, it's very much a joint programme there for all of the risk management authorities. All of our outputs are freely available, and as I mentioned earlier, you can actually find all of our past research going all the way back to pre-2000 in some cases, and certainly back to 2005 on our joint programme web pages. There's a great search function if you'd like to give that a go in a spare moment. Hyperlink to the web pages is there on screen at the moment, but as I said, the easiest way to find those pages is just a Google search on flood research Environment Agency. It'll be the first thing that comes up. We've also embraced Twitter, and we're often tweeting about our research outputs and other research relevant to flood and erosion risk management. So our Twitter handles there at FCERM Research EA. And if I could encourage you also to, if you haven't done so already, to subscribe to our biannual newsletter, Research News. you can subscribe again via our web pages, but that's a very useful newsletter where you can get a very quick overview of where we are in the programme and what's going on. So the joint programme itself occupies a bit of a niche between academic research and the operational needs of the risk management authorities. So we're typically trying to pull in research from the academic sector in terms of basic and applied research that they might be doing, and then we actually then further develop that research, typically prototyping new methods, tools, piloting them in real life situations, operational situations that we might find, and then we'll be working to develop products that we can then introduce to our business or the other risk management authorities. Typically they might be tools or guidance or data sets. So we're working both ends of that spectrum. We're working with the end users to try and actually understand their needs and challenges, and using that information to influence upstream the basic research agendas of academia and the UK research councils. So we're trying to pull through a constant flow of research and embed that into practice. As I said, I'm the asset management theme lead within the joint programme. So the joint programme is split thematically. It has 3 themes. Policy, strategy and investment is a theme that we jointly run with DEFRA. We also have an incident management and modelling theme, an asset management theme, which is the theme that I manage. This asset performance tools project, unsurprisingly, fits within that theme of research and specifically contributes to our thematic objectives to help us understand better asset performance so we can ensure that it performs optimally under normal service conditions and resiliently and predictably under extremes. And specifically, we're trying with these tools to really drive efficiency by improving the whole life cycle management of our flood and erosion risk management assets. So there's some specific drivers for this project. Really, as I mentioned, we're trying to improve our understanding of the costs and benefits of our maintenance actions. So this work is really focused at understanding the benefits and costs of our maintenance work on our flood and coastal risk management assets to improve our decision making. It builds on well over 10 years of research and practice, perhaps most notably before the PAMS project, Performance-Based Asset Management project, and a number of strategic drivers actually pushing this project forward, including our own Environment Agency asset management strategy. Organisationally, we're pushing for ISO 55000 accreditation, and we've got a number of internal programmes as well that this research will be supporting and feeding into. Just to point you in the direction again of where you'll be able to find the outputs of this work. Again, it'll be published on our web pages. We're hoping to push all of this work through our publication process and approvals process, so it will be available in early autumn. Okay, so at this point, I'm going to hand over to John Wicks, and John's going to be able to give us an overview of the project and introduce some of the tools produced. John, I'm just going to hand you presenter rights now.
Great, thank you, Owen. So, as Owen said, I'm John Wicks. I'm a global technology leader here at Jacobs. And I've had the privilege of being the overall technical lead for this Asset Performance Tools project, working with the experts that we've mentioned from within Jacobs, HR Wallingford, Haskoni, plus a wide range of other experts and stakeholders. Sorry, Owen, have you transferred it to me?
Sorry, first mistake there. I've transferred it to Jonathan. Let me try that again. Jonathan, would you mind moving that to John, please?
Okay, go. So hopefully I've been able to move the slide over now. So what I'm going to cover in this sort of 15 to 20 minute part of the webinar is a little bit on the process we went through for developing the guidance and tools, and very little bit on the type of outputs that we've generated. Then I'm going to talk about the overall asset performance tools framework, and then go into just an overview of some of the key outputs. And then I think once I've gone through that, it will help you decide which of the subsequent sessions within the webinar that you'd like to join into. So let's start with the process that we went through, and it was very much customer driven, to use the jargon. So a lot of that was through a series of workshops with a range of user types, both operational staff and those who are there to define processes, covering both national and local, regional levels. And we did that with a range of organisations. It definitely wasn't just the Environment Agency. So with those workshops, we were able to sort of refine and affirm the scope, particularly focusing on identifying the gaps in the current tools and guidance where there was potential for new tools and guidance to develop real benefits in terms of improving decision-making and efficiency. And we also used those workshops to really help develop a set of underlying principles that we used through to help us guide us through the development of things. So risk-based, now risk-based can mean a few things, but we're here thinking it's about the making sure that when we're assessing performance, we're thinking about the range of appropriate failure modes, thinking about rates of deterioration, thinking about local data and sort of generic national data, and we're thinking about the potential impacts if there was a failure to perform, and covering a range of driving triggers, whether it be coastal or fluvial rainfall. Think about the loading events and covering all of those. We wanted to ensure that we're producing approaches that were tiered, proportional, hierarchical. So tiered means there's simple tools for simple situations, very low cost of using them, don't need a lot of skills to apply those. But where it was necessary to transition to more complicated methods because of the scale of the problem or the issues with the problem we're trying to come up with guidance on, we moved to more complicated tools that will probably require more data and perhaps more skills to use them. So essentially, we're trying to make sure that the analysis effort is commensurate with the sort of type of decision you're trying to make. Practitioner-driven, so as I talked about the workshops already, but there was also throughout the life of the project, there was a lot of touch points with practitioners to make sure that we're producing things that could really be picked up. We wanted to, it's a bit silly this next one, sensitive to the effects of maintenance. So we wanted to make sure that the tools and guidance we produce were actually relevant for the particular types of maintenance that were being considered, and making sure that when you go into analysing that, it's actually the full line of sight from the maintenance activity to how that impacts on performance of that particular flood defence asset. We wanted to enable people to optimize. Now, optimize can sound really complicated and a lot of calculations, but it doesn't need to be that. We had to enable people to think about the balance between the investment, whether it be rebuild or maintenance, these sort of things, and how that impacts on how it delivers benefits, and also think about whole life aspects of the asset. And we wanted, where possible, we wanted to produce tools that could be immediately picked up and used, so they're business ready. I think this is saying a little bit about what Owen mentioned earlier, that readiness for use diagram at the bottom. We're very much focusing on outputs that could go into piloting or into immediately be introduced into the business. And the types of outputs we produced are tools and guidance. We had to do some method of development for some of the tools, so that's there, but it's not the main product. and we didn't actually generate any new data, although we did provide guidance on use of existing data. So let's move over to the framework. Now, this diagram on the left-hand side explains the 4 key components of this asset performance tools system. So we've got, starting in the, whatever that is, that sort of 10 o'clock point, inspection, performance, risk, and then planning. Now, these are all interrelated, and you don't necessarily start at any one point in there. You may be partway through some analysis or some decisions, and you could start using our tools, say, just at the planning phase. You don't need to follow the whole of that circle through. The tools and guidance that we've developed are all aligned with particular components within that framework, and you'll see that as we talk it through. You can see the different colour coding from the light blue through to the dark blue. Now, these are the tiers in the analysis method. So as you're on the outside of that diagram in the light blue, you're using relatively simple methods that don't involve a lot of data, don't involve a lot of analysis. So visual inspection using condition grade as a surrogate for performance, using target condition grade to bring in some risk elements, but not detailed risk elements in that way. And the aim is, where possible, stick towards the outside of that diagram in terms of the methods, because that's the cheapest approaches to apply. But you will have to, for certain circumstances, certain assets, certain decisions, move into more complicated. The recommendation would be to move into more complicated methods where it's proportionate to the level of decision you've got to make. Within the whole of this, it's trying to promote a whole life analysis, looking at risk, promoting a proactive approach rather than a reactive approach. Importantly, in the middle of that diagram where it says asset information, so it's the data and the information, so they're 2 slightly different things, are really important in order to make use of these tools. And we've set it up so you can bring in soft knowledge. It doesn't have to be quantified numbers. It can be soft knowledge about whether this is, it's more like this than that, or, well, it doesn't really fail very often, so therefore perhaps we could change the approach to this. It allows you, the whole number of these tools allowed you to bring in that soft knowledge. So this diagram shows you a summary of the tools and guidance that we've produced. So starting on the top left is the inspection guidance document that was provided, generated in the previous part of the program. Then going clockwise around there, we've got the custom fragility curve tool that I'll explain a bit more in a minute. We've got tools to help with channel maintenance, conveyance maintenance tool and guidance. Bottom right, we've got some documentation to help people understand what existing risk data sets are available and how you could use them within the asset management context. And then moving to the bottom arm, the planning arm, we've got the whole life cost appraisal tool, which I'll explain a bit more about later. We've got tools and guidance to help you with setting triggers for interventions on beach management. And then on the on the left-hand side, where it says risk-based appraisal tool prototype, that's one I'm not going to talk about today because it is really a prototype. It's not ready for take-up. It was some preliminary work to come up with an approach that demonstrates how you could pull in full risk information, performance information, deterioration, and go through a whole life cost appraisal type approach to think about benefits, cost benefit, incremental benefit cost ratios and this type of thing. And then we've also produced a summary report that covers all of these things. So let me just say a slide or two on most of those things next. This is an introduction to these so you can better understand them. So as I said, under the inspection arm of the framework, a previous phase of this project produced asset inspection guidance that provides both generic inspection advice that's applicable to all asset types, and then for some specific asset types, there's some specific types of advice. It covers the 3 tiers within the overall framework. So tier 1, which is the outside, lighter blue, simpler methods, routine visual inspection, through to more complicated intrusive inspection methods where it's justified, where it's needed. It's not just the guidance doesn't just cover the inspection of the asset. It covers some of the health, safety, environmental considerations around that process. It was developed because there's a real need to produce, to share best practice, to enable efficiencies, and importantly consistency between the asset inspections and the condition grades that came out of that, and apply a risk-based approach. It's already out there. It's already being used, so it's delivering benefits, as covered by those last couple of bullet points. So moving on to the things that we've developed through our work on the Asset Performance Tools program. The first one is, we have a few names for this, but I'm going to call it the Custom Fragility Curve. And this is a tool that allows you to adjust generic performance curves, fragility curves, whatever you want to call it, to adjust those, bringing in local knowledge, but to do it in a very simple, easy to use approach using minimum new quantified data. It's needed because the existing fragility curves, which underpin a lot of the decision support tools that are used, particularly in the Environment Agency, those generic curves can be locally quite inaccurate. To regenerate those curves from scratch can be an expensive, complex and data-hungry approach. And therefore, we wanted something that was sort of like a step beyond the generic, on the generic curves, but in a simplified way. So Jonathan's going to talk much more about this later on. So I won't go into much detail on it, but it's there to bring in that local knowledge. If you've got the local knowledge within these curves, then you're more likely to believe them and use them. This is a couple of screenshots, or 3 screenshots from this fragility, custom fragility curve tool, where you go in and you can say, well, there's a generic curve here. If I look at the sort of a photo of what that defence should look like for a central estimate. However, the defence I've got here is much more like this, nearer to, it's got a wall in it. It's not a composite defence, or it's got its condition grade is better or worse than the sort of the standard condition grade 4 or whatever. You can move sliders, as shown in that central picture there, to move to say it's much more like this, much better, and this about the same, and this sort of thing. And then through that process, and putting in some other data, it will then come up with an adjusted curve, which will then help you understand the probability of failure of that defence subject to particular loading, which can then influence the decisions you make on best times for intervention and things. And as I said, Jonathan will explain that in his session. So that was for sort of linear defences, embankments and walls. If you now think about channels, and conveyance assets. So we produced both a guidance document and a tool to help with channel conveyance assessments and thinking about the different levels of maintenance and how they impact on the performance of that channel. In terms of the guidance, it goes through a range of different, explains a range of different methods you can use for calculating the impact of changes, such as removing blockages or different levels of channel vegetation cutting, how those changes will impact on water levels and or flows, depending on the way you look at it. Again, it's got this concept as these 3 tiers of method. It's a very simple method, sort of a medium complexity method, and a detailed method. And it's given some advice. For example, if you've got a tidal channel with big sediment problems, you probably need to be moving into one of these more detailed, medium or detailed levels of analysis. However, there's other situations like a relatively straight channel, constant slope with just fluvial flows, then a simple approach such as the tool that we'll explain in a moment could well be the most appropriate approach for understanding how different levels of weed cutting could influence water levels for particular flows. So we needed this guidance because there was, our stakeholders were telling us there wasn't sufficient information available explaining the range of methods and data sets that are already in existence. So it's a good way of sharing the good practice to enable better decision making. Almost as important as that is it provides a structured way for people to assess and then communicate the reasons why there'd be a change in maintenance, and importantly the withdrawal of maintenance, or withdrawal of dredging, or a withdrawal of grass cutting and things. If you can show that you've gone through this approach, here's the calculation, this is why we've done it. It will help you with those stakeholder discussions, I hope. So it's there. We developed the guidance to help decision making, share the good knowledge, share the best practice, and also help with stakeholder acceptance of where there's going to be a change in the maintenance, or probably the withdrawal of maintenance. So the guidance is there and it's ready to use. It's just a document, but associated with it is the is the vegetation and roughness tool, which Marta was going to explain more about in her session. So it provides guidance to decision-making on maintenance in channels by allowing you to put in some information about that channel, very limited amount of information, sort of dimensions, slope. You tell it what sort of vegetation and sediment it's got, and then you can try different amounts of maintenance, vegetation cutting essentially, and then it will tell you how the water levels will change for a particular flow, and you decide what flow you're going to use to drive this, as a 1 in 10-year flow or whatever it is. So it's a structured way of working that through and should help with the evidence for the decision making, and hopefully help with people understand why that particular decision on the change in maintenance is going to occur. And it's a tool that works inside Excel. You don't need anything special installed on your computer to use it, so it is available for use. Here's a few screenshots of it to give you a feel for it. So there's a series of tabs along the top. You put in the data, such as I said, the bed width, the channel depth, the slope, vegetation material. You tell it what type of change in vegetation management, so where you're going to cut the reeds out or whatever it is, cut the grass, and then it will come up and give you the curve you're seeing on the bottom there, which tells you for a particular flow what the water level would be with and without that intervention, and therefore the benefits of that intervention in terms of water level. Moving on to the under the risk arm. So in that, what we found was there's a lot of data sets on risk information, so impacts of flooding under different interventions. A lot of that data sets exist and have been some developed recently, some further back, but there wasn't really any guidance on where what that data set looks like and how it could be used within asset management. So we put together this guidance document to bring all that stuff together in one place. There's two primary audiences for this guidance document. One is for those who need to make operational decisions or policy decisions locally, and they want to work out what data is existing that they can use to help with that. And then the other audience for it is those who are specifying new modelling, who want to know what attributes should be in that new modelling to make it a best use for asset management decision making. So the benefits of it puts all that information into one place, shares the good practice and the knowledge of the data, which should lead to efficiencies and better decision making. It's a guidance document, so it's ready for use as is. Moving on to the planning arm on the framework, a few tools in here. The first one is the whole life cost appraisal tool, where you it allows you to investigate the changes from or the relative benefits of different levels of maintenance, from sort of low level of maintenance to a lot of significant maintenance, perhaps with refurbishment built into it as well. It's a whole life approach, so you look over a time period of 50, 100 years or whatever. It will calculate, it will come up with where the optimum points for these maintenance interventions are. It's driven by achieving a target condition grade. It covers both linear and point assets, and it's got built into it deterioration curves showing how, predicting how different assets will move between different condition grades over time. But importantly, we've built into the tool the ability to bring in some local soft knowledge to adjust those deterioration curves. So if you've got evidence that your particular defence is deteriorating at a faster or slower rate than some of the standard curves, then you can adjust those deterioration curves to bring in that local knowledge to make it more appropriate for the actual defence that you're applying at. So Alec is going to be explaining more about this tool in the follow-on session. It is a bit more. It's available, isn't it? It's an Excel tool. It is a bit more complicated to use than some of the other ones I've talked about, so it does need perhaps more data and more knowledge to work with it, but it does provide a really nice consistent approach, and it enables this move towards a whole life approach for asset management decision making. The other key tool in the planning arm of the framework is the stuff to do with the setting triggers for beach management intervention. So Jaap will explain this in his session. by talking to the stakeholders and seeing what was happening in the local authorities, it was clear that the existing guidance isn't the beach, as it was the beach management manual, isn't really practical for applying. So we developed the method and the tools to come up to implement a practical method to help set the triggers, which are then monitored to see to be proactive in terms of your beach management. There's a second objective to it as well, is it really helps understand, it helps knowledge gaining to understand the processes better by the way it's set out. And as I said, the aim is to be proactive to limit, hopefully remove the failures where we have to go in afterwards, such as the storage stuff. And should lead to a more optimal spend of the local authority maintenance budget, with a clearer justification about why the decisions have been made to intervene or not to intervene at different times. It's available for use. It's guidance documents with flowcharts in it, and it's a software tool that guides you through that. So I said Yap will lead us through that. The other final main deliverable is the final report, which, as Owen said, will be going through the publishing process. It provides an overview of the project, describes in more detail the drivers, the needs, the principles, describes the framework, and then goes through and summarises the projects and provides some case study information about how those products have been used, can be used to help you understand their appropriateness for the decisions you're going to need to make. So to recap, we've gone through in a little bit more detail those tools: inspection guidance, fragility curve, conveyance tool and guidance, the guidance documents on the risk data sets to help you know what data sets are out there, the whole life cost appraisal tool to help with trying to, on a whole life cost basis, understand what are the optimum maintenance regimes to minimise whole life cost, and then the beach performance tools. As I said, on the left-hand side there, the risk-based appraisal tool prototype, we're not going to say anything more about that because it's not appropriate for use at the moment, but just demonstrate some of the concepts. And with that, I'd like to pass back over to Owen.
That's great, John. Thank you very much for that overview, and it's very good to see the overview and actually appreciate the amount of work that has been done under this programme and by the project team. So thank you very much for that. I'm going to attempt another poll now, if I could. I realise that you probably didn't see the results of the last poll. Candy, can you help me with this poll at all? Candy's gone quiet. Okay, I'll give it another go. So I'm going to open the poll on the right-hand side, and if you could just indicate which of the tools you think might be valuable to you in your job. I will have a look at this software and see if I can get the results to graph. If I can't, then I'll just describe them again to you. Okay, I'm going to close the poll, which will just give us 10 seconds or 20 seconds just to finalise your selections there.
I mean, I would say that the way the poll is set up, it only allows you to you can only choose one, which is not the intention. I think a number of people and organisations we were hoping that a number of the tools and products will be useful for their particular role.
Yeah, no, good point, John. I've just came to the same realisation as well. So apologies for that. It still gives us a little bit of useful information, and actually I'm not going to attempt to graph the results. Apologies, but I will just say that the distribution across the tools is actually fairly even. So there seems to be interest in all of those tools from the different sectors. So, yeah, appreciate everybody taking the time just to click on those buttons. Thank you very much. Okay, I just want to move into just a very quick slide on how we in the Environment Agency are starting to think about embedding some of these tools in our operational practices. So as John mentioned, the inspection guidance is out there. It's been published for a while and is currently being used, and it's guiding the development of our T98 inspections, but also our post-inspection process. The fragility curve tool that John described, again, that will be published and will be free to download and use, but specifically a lot of the thinking that has gone into the development of that tool is now actually going into an initiative that's being led by our national asset and performance engineering team to update our risk-based field tool called RAFT. The conveyance guidance and tool, again, that will be published and be freely available to be used. Within the Environment Agency, we're looking to see how it can support our channel conveyance KPI, Key Performance Indicator 965. Risk data set guidance, that document and guidance was very useful in feeding into the development of our National Flood Risk Assessment specification and our Creating Asset Management Capacity programme. The Whole Life Cost tool is, as John indicated, is slightly more complex. Again, it will be freely available, but it's probably more in this proof of concept category. It's currently being used by the team working on Thames, Team 2100, within that asset management programme, so it's currently being piloted there. Just to point out the beach performance tool and guidance that we'll hear about from YAP if you dial into that session. We're currently in discussions with Syria about actually making that as a formal addendum to the beach management manual. So we're thinking about how to embed all of these tools in our operations currently. So I'm just going to move to the Q&A session. I've got a few questions just come in over the chat function, and I'll try and direct those to the team. So the first one I think is probably best dealt with by me. Are all the tools and guidance referred to in John's presentation openly available to all of the risk management authorities? Is there an easy way to find them? E.g. search on the FCERM Research pages? Yeah, great question. Thank you for that. Yes, they are all going to be openly available. We're yet to publish them. We're hoping to push all of this guidance and tools through our own publication approval process, and they'll be available in early autumn, I hope. What we will do is write to everybody that has registered interest in the webinar, just to let you know when they are available and where to access them. But they will be hosted on FCERM Research pages, and if you just search Asset Performance Tools in the search function, you'll find the project page. Hopefully that's answered that question. John or Marta, maybe you could take this one. Could the conveyance tool be used to calculate the impact of removal of a historic water level control structure, a weir or mill, for example, within a channel?
Hi, it's Marta here. Right now it cannot take into account the removal of structures. So right now the tool is focused on changes on the vegetation in the channel, in simple channels. So I'm afraid not yet.
Okay, that's great. Thanks, Marta. Okay, so those were all of the questions that I can see via the chat function. Candy, if you're on the line still, could we open the lines and take any questions over the phone?
Certainly, sir. Ladies and gentlemen, we will now begin the question and answer session over the phone. If you wish to ask a question, you may press *1 on your telephone keypad and wait for your name to be taken by an operator. If you wish to cancel your request, you may press the # key. Once again, ladies and gentlemen, over the phone, *1 if you wish to ask a question.
Owen, I think it's worth pointing out to everybody that there's also question and answer sessions in the subsequent breakout sessions, and if people have got questions that are specific to particular tools, it may well be best to hold on and either see whether the second session covers those or ask a question at the end of that those breakout sessions.
Okay, John, thank you.
And it seems like we don't have any questions over the phone. Please continue.
Okay, thanks, Candy. Okay, so this brings to an end the plenary session. If you'd like to find out more about the defence performance curves, fragility curves that John outlined, you can stay on this session and where you'll hear from Jonathan Sim at HR Wallingford. Likewise, if you want to hear more about the whole life costing tool, again, stay on this session where we'll hear from Alec at Jacobs. So that those next two detailed overview of those tools stay on this session. If you're interested in the watercourse maintenance aspects and the guidance and tool that has been developed there, can I ask you to log out of this session and redial in on this number and using this hyperlink that was in the agenda that was circulated. What I will do is just post that hyperlink there. So that's the channel, watercourse channel maintenance session. Those sessions will be starting at 11:25. So you've got, if you're joining one of those, you've got 5 minutes. Likewise for the beach management, if you're interested in finding more about beach management tools and guidance developed, we'll be hearing from Jaap Flikvert at RHDHV. Again, dial out of this session and dial back in using those details there on the phone and with the WebEx. Again, I'll post the link to that. There. Okay, we're going to take a short 4-minute break. We're going to start this session again at 11:25, where we'll be hearing from Jonathan Sim. If you'd like to take a comfort break and dial into the relevant sessions that are of interest to you, then do so now. Hi there, Candy.
Owen, can you hear me? Jonathan here. Hello?
I can hear you, Jonathan.
Okay. So just the question is are we making the slide decks available to participants as PDFs?
Yeah, I don't know the answer to that.
Okay.
I don't know how they would do it.
Yeah, the plan is to do that. So it'll be available on the same website like the recordings.
Thanks.
I think the 5 minutes are possibly nearly over, so it might be worth starting. I believe Owen has joined the conveyance webinar.
Okay.
Jonathan, can you confirm you can move the slides forward?
Yes, I'll do that now. You've transferred control to me?
Owen had control.
Yeah, has he gone for a moment?
John, to me it looks like the control is still with you.
Just give me a minute.
Yeah, the control is with you, John, that's it. Mm-hmm.
Can I suggest we make a start so that we can finish by 12 o'clock?
Indeed. I suppose what I'm unclear about is whether, because we had that music happened, as to whether or not participants can actually hear me at the moment.
You are live now. Please go ahead.
Okay. Thank you very much. Well, good afternoon, everybody. My name is Jonathan Sim, and I'm just going to make a short presentation on this custom fragility tool that John Wicks introduced in his presentation. It deals with the performance arm of the asset performance tool diagram. So in starting this, I really just wanted to demystify a little bit the idea of a fragility curve. I think a lot of people understand that now, but very simply, it just expresses the increasing probability of failure of a defense as the load on that defense increases. And that is important, that is important to us and to the Environment Agency at a regional and national level, because it allows the defence performance to be included in flood risk systems analysis. But it also allows engineers and practitioners to think more deeply about how their defence is actually performing as loads increase on it. We can have generic curves that John mentioned, or we can have curves that are much more bespoke for individual assets. Right, sorry, excuse me, one moment. Okay, so the concept in the whole Asset Performance Tools project is that of a tiered approach. And as John explained, the outside of the wheel is the blue, where we're using very simple approaches. In this case, it's just condition grade. And then the mid-density blue is actually a more simplified reliability analysis, where we're just relying on those generic curves. And then the tier 3, the dark blue, is the asset specific reliability, where you're going into detailed analysis of those individual defences. And in this particular case, this tool that we're talking about is somewhere between tiers 2 and tiers 3. So the generic fragility curves, which are commonly used in the National Flood Risk Assessment, rely on the underlying asset representation used being accurate, and that's obviously not always the case if the geometry is different or some other aspect of the structure is different. And the idea of this is to get to a more realistic representation for a specific asset by rating the asset's likeness to a collection of different attributes about the defence. So it's taking your knowledge about that defence and trying to reflect that in the form of the fragility curve. So the principle behind it is that of fuzzy logic, and I think the easiest way to explain fuzzy logic is to think about the way that you punch numbers into your smartphone, and you'll be aware that sometimes you slightly miss hits, but most of the time the smartphone is reasonably friendly to you, and if you don't quite hit the center of the number on the pad or whatever it might be, or the letter, it works out which one you really meant to use. And essentially the way it's doing that is by working out which number you're nearest to, or which figure you're nearest to, and that's essentially what we're doing, using that basic principle to bring together the information that we've got in this particular situation. And we use this membership function where we're saying on the bottom, depending on how alike you are to a particular attribute that you're trying to represent, that with the software then says, well, then it's more like this attribute or that attribute. So I'm just going to quickly run you through the tool with a few screenshots. So it's an Excel-based tool, so it's very easy to access. And you get this opening page where you just click on this button, Custom Fragility Tool, and then you go into the opening page where you enter some information about yourself and about the asset that you're looking at. Then the next page allows you to put some information about the defence into there, and what its functionality is, whether it's protecting against, whether it is directly protecting against flooding, whether it's a coastal asset where it's exposed to sea waves, or whether it's just exposed to water levels. Then the next screen on the right-hand side gives you an opportunity to say, for this particular defence, which type of structure it's most like. So if you take an example, we might well have a flood embankment, but it might have a vertical wall, a crest wall on it, and you make an assessment based on this as to whether the vertical wall component in this particular slide is more like is a sheet pile wall or gravity wall or an inclined wall. The next slide on the the next image or screen, as it were, on the left-hand side of this image, you can start putting in some information about whether or not the structure surface is protected, and you can that's just the basic information. And you can also, at the bottom there, give some information about how steep the slope is, and you may not know that exactly, but there's a slider bar there for you to assess that. Similarly, there's a slider bar for you to estimate the asset width. Then on the right-hand side, you can make some kind of assessment here as to which condition grade the structure is in and what proportion of the asset is in that condition grade, again using slider bars. We go to the next slide. Here you can, on the left-hand side, there's a screen where you can select the type of material that in this case, the flood embankment is made of, whether it's sand or clay or some kind of mixture. And you can also put in evidence, for example, of whether the asset has withstood a recent large flood event, where we can take that information into account. And then on the right-hand side of this particular slide, we've got the final product that pops out. So here, in this particular case, you'll see the 5 generic curves, which are the condition grade 1, 2, 3, 4, and 5, in the various colours, and then you'll see in the dotted line your specific curve that you've generated by means of going through this tool process. And there's a button at the bottom right-hand side of this of that screen when you're operating it, which enables you to export the results into a spreadsheet file or whatever format you need. Owen asked me to mention, and I think he alluded to briefly in the plenary session, that we're actually moving, we've moved effectively from generic curves to this custom tool that I've just described, and the Environment Agency seem to be now keen to move on to something which is really more like a Tier 3 tool. And here, what is being developed for them is a means of actually accessing their database of assets through the AIMS database. So you've got on the top right, you've got a web interface that you can access. So this isn't an Excel-based tool, this is a web-based tool. And then in this particular case, you enter specific information about the tool, specific information about the asset. So, for example, importantly, geometry. So the difference between the two tools here is that the previous one you can probably run through in 5 or 10 minutes, whereas this one might take you, say, an hour to go through, because you have to go through and think quite carefully about the parameters that you're putting in at various places, but you'll talk through it on an expert judgment base. And again, you get fragility curves coming out of that process. So it's the kind of thing that a catchment engineer could run through with his knowledge of the site. So if we move on to the summary of this particular tool, so the custom fragility tool allows people to estimate the probability of failure of linear assets using their local knowledge to adjust those generic curves. And if we move to the final slide, it's ready to use. It's just an Excel plugin, so it can be used, and we believe it's got to the point where it's a useful tool. The way that the Environment Agency finally rolls this out has not been decided, because it's accessible to everybody now, product available now. They may decide to make more use of a more detailed tool. It depends on the balance of interest, I think, in whether you want a very specific fragility curve, or whether this intermediate step that we've done under the Asset Performance Tools project is more appropriate. So thank you very much.
Okay, thank you very much, Jonathan. It's Alec, you all know, and I'm going to talk to you a little bit about the whole life cost tool. So Jonathan's just handed over the presentation rights to me. So my name's Alec. I work at Jacobs in our asset management group here, and I spend time thinking about how we maintain assets and operate them over their whole life. The tool I'm going to talk about sits in the planning quadrant within the APT sort of classification system. I'm going to go through a background to the tool, if you like, the foundations that we use to build it, provide you a brief overview, and then give you kind of an example of the application of a tool to a particular use case. So what does it do? Well, it enables us to investigate alternative investments to maintain the assets, and we're talking about linear and point assets here. We're thinking about investments to maintain those assets over their whole life. We're thinking about maintaining a target condition grade, and to do that, the tool incorporates a set of deterioration curves which we can adjust with local knowledge if we've got some information about the way those assets are deteriorating. We're using the tool because we want to improve decision making. We want to make sure we're making the right investments over the whole life, and I think it helps bring a consistent approach to long-term planning, and it's the sort of thing we need to do if we want to demonstrate an accredited approach to asset management, such as ISO 55000. So what is whole life costing? Well, whole life cost analysis is about comparing investment options for maintaining physical assets. To do it, we have to develop projections of interventions throughout the life of an asset, with the purpose of trying to identify the optimal intervention strategy. And for flood defence assets, then we're talking about investments that can include, say, or interventions that include annual maintenance and different qualities of annual maintenance, midlife refurbishments in those assets, and also longer term perhaps replacement of those assets. And the tool endeavours to deal with all of those things in several ways. The foundations for the tool were set out in a technical report on deterioration and whole life cost. That report was put together in 2009, and it also generated a Excel sort of based whole life cost forecasting tool, which has been the basis of what we're going to show you now. That report developed for a useful asset classification system and hierarchies for things like asset types, how we apply deterioration rates to those asset types, the types of interventions we want to make, let's say the annual maintenance, the refurbishment and the replacements, and also some sort of guidance for the different types of maintenance and the whole life and the costs of making those types of interventions. So onto the tool itself then, to give you a quick overview. So it's based in in Microsoft Excel. There's a few complex things going on behind the scenes, and we've tried to encourage a kind of a process to help you navigate your way through the tool. So we've had to include some macros to do that. We've enabled saving and loading of different appraisals. So that's quite a useful feature to be able to utilise work you've done before and base new appraisals on data and information you've entered previously. So it's got these built-in deterioration curves and the ability for the user to adjust and define their own deterioration curves. We can also model the construction of a new asset in the tool, so that's quite an interesting development where we can look at the benefits of constructing an asset of a different type at some point in the future to replace the existing asset. We encourage people to view the whole life costs and overwrite any unit cost assumptions if with more local knowledge, and that's available. So an analysis comparison of different annual maintenance regimes, say refurbishment during the midlife of an asset and then perhaps asset renewal at the end. On the right of the slide here, I'm just showing the process that you're encouraged to work through as you use the tool. So you can start a new appraisal or load an existing one. We then look at to review the whole life cost profiles and costs associated and condition profiles associated with different annual maintenance regimes. We can then think about defining a new deterioration curve if we need to do that. We can select a new asset if that's something we wanted to do and define that asset. Then we have the ability to compare a whole range of alternative types of investment in terms of when and how we make those interventions to maintain the asset, and then we can save the information and create a printout and get sort of annual forecasts of what we think the costs and the condition are going to be from the tool. So the tool is designed to support decisions and not make those decisions for you. So I'm just going to go through a couple of slides now which give you sort of a bit more detail about those steps. So the first thing you have to do is define and review some of the assumptions associated with the asset that you're assessing or appraising. So there's a series of screens that take you through defining the type, the environment that the asset's in, the expected deterioration rate, whether it's fast, medium or slow, the dimensions of the assets which are used to understand the costs, the accessibility of the assets which also influence the cost of maintenance in some cases, then also what the current condition grade of that asset. So there's a series of kind of forms you work your way through, and it's providing you some information about, say, some of the failure modes you might expect to see, and what some of those deterioration rates and selections mean for you. So in step 2, we're looking at comparing different standards of annual maintenance for that asset, and I've put in 3 screenshots here. So typically we're looking at a low standard of annual maintenance, a medium standard and a high standard. So that's really about the quality of the maintenance that we're applying to those assets. And on here in these screenshots, the dashed lines that are kind of like a sawtooth pattern are showing the forecast of condition. By condition grade do we expect to see. The solid blue line, which is increasing with time, is showing the cumulative whole life costs associated with those maintenance and refurbishment activities. And then the grayed out area is showing what we've set as what we think is a minimum standard of condition grade we want to see for that asset. So as we move through applying higher standards of annual maintenance, then typically we're seeing fewer interventions over the whole life because we expect that higher standard of maintenance in some way to offset the deterioration that we've set for that asset. The next step would then be to think about the deterioration rates we've got and whether we've got some information we want to use to assign our own deterioration rates based on local knowledge. So at this stage of the analysis, we're looking at the time between transitions between condition grades, and you're allowed to make some changes within kind of a defined scope for the type of asset you've selected. If you've got some historic condition information, you can overlay that on the graph to help you define the deterioration rate. And if you've got some assessments of what we think the condition might be at some time in the future, you can also overlay that information, and then you can use the sliders in the tool to drag the deterioration curve around and define something which you think is representative locally of the behaviour of that asset. You can also, as I said, define a new asset, so that might be something where that might be used in a case where you want to compare the cost of constructing a different type of asset and maintaining that perhaps lower maintenance asset into the future compared to the one you've got now. And again, there's a set of screens that take you through that, which look a lot like the screens that we used to define the asset originally. But that can be a different type of construction, and you can compare that different type of construction to maintaining the asset you've got at the moment. And the final stage then is a kind of a screen that enables you to overlay various comparisons and view various different intervention options. So in here you can choose to display different annual maintenance regimes, and then you can also adjust the mid and end life interventions in terms of how much life extension you might apply to the asset by spending money to improve the condition grade. And then you can also choose to overlay the construction of a new asset of a different type on that chart as well. And again, here the solid blue line that's increasing with time is showing the whole life cost, and each kind of step in that whole life cost profile, which is cumulative, shows money spent on some form of maintenance. And then the dashed line is showing, again, the sawtooth of forecast condition grade. And this time we've got kind of a grey line, which is showing our minimum acceptable condition grade or target condition grade over the asset's life. Those costs are discounted, so we can see each time we're completing an activity, we're seeing it's effectively looking to cost less as we're moving into the future. And there's a set of controls on the right that let us change the extent of those intervention activities and how much we're looking to spend it over time. So I'm now going to have a quick look at a case study. So this is for an asset on Canvey Island, and we're thinking about what maintenance regime might yield the lowest whole life cost for that asset. So it's a vertical wall, it's made of brick, masonry and concrete, 384 metres long, target condition grade 2, 6.7 metres at crest, and design standard of protection is 1 in 1,000 for that asset. So we're going to look at 4 different regimes using the tool. The first 3 regimes are really thinking about different standards of annual maintenance again. So option 1 is thinking about the lowest standard of annual maintenance. Option 2 is kind of the medium standard, regime 2 of annual maintenance. And option 3 is the highest standard of annual maintenance. Option 4 then we're going to look at and to think about what we think the lowest whole life cost could be for that asset. So there we're going to start thinking about midlife refurbishments and what benefit they might bring. So again, these are the kind of charts that we're presenting in the tool that will become quite familiar. So this is annual maintenance regime 1, the lowest standard of annual maintenance, and we're forecasting a whole life cost of 4.18 million for that asset over 100 years. Again, that's discounted. We can see the sawtooth of condition moving forward with time and the steps in the cumulative whole life cost curve. And here we're forecasting 5 major improvements over the 100 years. If we then look at option 2, so this is a medium standard annual maintenance, so we can see a slightly lower whole life cost, so 3.59 million, and here we've only got 4 major improvements over the 100 years of analysis. So we're seeing the impact of the higher standard of annual maintenance on the deterioration rate. So we're forecasting fewer future major refurbishments. In regime 3, again, this is the highest standard, and the whole life cost has come down to about 3 million. And again, here we're seeing 3 major improvements rather than 4 or 5 that we saw previously. So then the final stage is to think about what the least cost might be. So if we've selected annual maintenance regime 3, and we think about what say minor improvements we can make over that asset's life, here we've looked at different combinations and established that we can drop the whole life cost a little bit further if we forecast some more minor improvements over the asset's life. So you can see in the condition profile we've got the asset moving from condition grade 2 to kind of 1.5 through some minor improvements over the asset life, and that's enabled us to extend the life a little bit further as we move forward and produce a slightly lower whole life cost. So the benefits then, we're looking the use of tools like this, in this case is based on our best available research, shows that we might be able to maintain the annual maintenance regime 3 plus refurbishments at condition grade 2, and renewal produces the least whole life cost. We can inform, it helps inform longer term investment needs. There's benefits of working through a structured process, and encourages us to think about options in a consistent way. We've got some evidence for decision making, which will help with, say, endeavours to achieve ISO 55000. And then we can identify least cost solutions as well based on the current best available evidence. So in summary, it's an Excel tool. There's some asset data and cost information that you need to use the tool to challenge the costs that are included. There's quite a lot going on in the tool, so it may be we need a little bit of training to move forward. The tool is being trialled and used on Team 2100, so it's being used for the assets in the Thames estuary. I think one major limitation of the approach as it stands is that we're talking about maintaining the target condition grade, so we're not in this tool thinking about the risks associated with maintaining assets in a particular condition grade. So we're saying we've already decided which condition we need the assets to be in and what the range is allowable. Then we're looking at the least cost way of maintaining that. Okay, so I think that's finished my presentation. So I'm happy to take some questions, and I think, Jonathan, we may have some questions for you as well, so I don't think you took any at the end there.
Yes, thanks, Alex. I'm open for questions as well. I think people can put questions into the chat function if they have any, or in the Q&A.
Thank you. Once again, ladies and gentlemen, over the phone, *1 if you wish to ask a question, and over the web you may chat your questions to the panelists. And I believe we have some questions over the chat.
Yes, as it's Alex, as I've got control, I've had a question from Nigel Horwell. Is asking about the discount rate that the EA applies. As it's long-term forecasting, then we're using the kind of social time preference discount rate, which is recommended in the Government Green Book. Okay, do we have any other questions out there, either for Jonathan or myself?
There seems to be some more chat questions on the costs.
We have on the Q&A panel.
Okay, so so Nigel's asked what the figure is. Well, it's a step discount rate. I haven't got I can't remember the figures off the top of my head, but it's something like 3% for a number of years, then 3.5%, and then another percentage after that. So if you pick up the Government's Green Book advice, you'll see those discounts rates and how to apply them, and a couple of worked examples there. But it is stepped over time. And it's supposed to reflects a number of the long-term challenges with forecasting and understanding costs over sort of periods of 100 years or so. There's another question that's come through from Kerry Deeks, which is where do the costs come from? Is the cost data managed in a central way like the cost tool? In this case, it's not the information, the cost data doesn't come from there. That's, I think, something we're going to explore moving forwards. When the initial work for this project was completed, that tool didn't exist. So some unit cost information was put together kind of to support the original project, and we've continued to use that here, but I think it would be in the future a good idea to see how we can link those two things together. I think the right thing to do is to challenge the cost assumptions that are in this tool, and where possible overwrite them with with more recent or local knowledge where you have it. Okay, that's a question from Andy Beverton, could you please elaborate a little on the main limitation of the whole life cost tool, condition grade orientated, that was mentioned in situations where another approach may be required? Are there plans to address this? The limitation here is that we're really thinking about the condition of the asset, and we're not thinking about the reasons for maintaining the asset in a particular condition grade. So I think the tool is useful in identifying a least cost to maintain the asset over its life in the target condition grade, but you need to have done some other work to establish what the target condition grade is, and that needs to take into account the risk associated with maintaining those assets in a particular way. So there we'd be thinking about using some of the other products or tools like the fragility curve tool, and also then thinking about what the consequences of flooding would be for that asset. I think there's been a couple more questions just about the cost. And so I think it's true, we do need to think carefully about the costs we put into tools like these, and I think we should try and align some of that information with some of the national information that's available.
So I think John here. So I think we've come up to the hour. So I think it's we've covered all the questions. So thanks very much for Jonathan and yourself to present on this. It's a very good presentation. And as Owen said earlier on, we'll be making all of these recordings of these presentations, and probably the I think we'll make the a PDF of the slides also available, and we'll circulate that information. So thanks everybody. Thanks for ringing into the webinar today, and I hope you found it useful. Goodbye.
Thank you, ladies and gentlemen. That does conclude our conference for today. Thank you all for participating. You may now disconnect.